I'll start off because I've got some housekeeping to share and some introductions, and hopefully during that time, people will start trickling in. Is that all right, Sarah, Adrian? Cool. Okay, great. Fantastic. Good evening and welcome. My name is Rose Dahlan. I am the Change and Engagement Manager with the Climate Change Transformation Team. Welcome to our second Net Zero Isle of Man Together for Our Planet webinar series, organized to run during COP26, which is currently happening in Glasgow, as you all know. Some housekeeping before we start. This event is recorded and we will share it on our YouTube channel and website and social media. So if you do not like your faces to be seen in the video, you can turn off your video, but you can still see the presentation and hear the presenters. At the end of the at the end of the presentation will take roughly about an hour, and we've allocated 30 minutes at the end of this event for Q&A. So if during the presentation you have questions, I would advise you to use the chat function at the top of the screen and type in your questions. And at the end of the presentations, we'll read out the questions for the presenters to answer. And last but not the least, as most of us are in our homes and there'll be some background noises, cat, dog, children. So can you please turn off your mic during the event to minimize any disruptions? So that's housekeeping out of the way. As we all know, COP26 UN Conference of Parties is a very crucial event where world leaders have been brought together to discuss actions to tackle climate change. And that's why Net Zero Isle of Man, we've been working with key stakeholders to bring together an on-island program of events to raise awareness of COP26 and climate action. And this presentation tonight is part of that program of events. And we are very, very fortunate to have with us two experts to talk about how climate change has impacted the Isle of Man. There are two presenters tonight. The first presenter is Adrian Cowin, who is the Senior Meteorological Officer in the Isle of Man Met's office based in Ronaldsway Airport. He's been an operational meteorologist, sorry, I can't pronounce the word, for over 38 years with an extensive background in providing detailed weather forecasts and weather warnings for the Isle of Man airports, as well as the island as a whole, and mariners in the North Irish Sea. And this experience has led to an increasing curiosity in weather statistics and the measured effects of climate change over the last few decades and the possible impacts in future decades. So Adrian today will be presenting and share with us how local weather has impacted our local weather has been impacted by climate change, and he'll also provide some very interesting future weather predictions. He will be followed by Sarah Hickey, who is a conservation officer with the Manx Wildlife Trust, who has a background in research in natural environment and outdoor and environmental education. She's always been interested in climate change and has been heavily involved in plans to restore upland peats on the island, both to improve habitats and reduce carbon emissions. And Sarah will share with us the impacts of climate change on different species and habitats. I shall also explain how nature-based solutions play a key role in mitigation and adaptation, and highlight some key related projects that the Manx Wildlife Trust are currently working on. So with that introduction, and without further ado, I feel we're ready to start the event today. So we'll start with the first presenter, Adrian. Adrian, over to you.
Yes, thank you, Rose. Hopefully everyone can hear me quite adequately, sat in my box room here in glorious Colby. And hopefully in a moment you'll also be able to see my shared screen. I will check on that, because if you can't see the shared screen, I'm in trouble, because I'll be talking to myself and you won't be able to see what I'm talking about. But first am I. Good evening, everyone. It's lovely to be involved in this event, the series of events for Net Zero webinar, and it's a pleasure to talk to you for a while this evening. I will be talking fairly briefly, or at least I'll promise it's much less time than I normally speak to organising groups. I normally get invited to speak for 25 minutes, 30 minutes, and 1 hour later I'm still talking and everybody's wanting a cup of tea and a biscuit. But I'll try not to do that for you this evening. We're going to look into a few topics this evening. Climate change, obviously, And I'm going to look at it with a view through an Isle of Man lens, is the way I'd put it. But before we do that, I want to take an opportunity to have a quick look at the bigger picture, the global picture. So you've got a background context and some data to look at, and that will give us the global picture. And I want to look at the regional picture, and then we'll zoom into a little lump of rock in the middle of the Irish Sea, which happens to be what place we call home, the Isle of Man. Will also, I think, be worthwhile, especially in this period of intense interest, international interest, COP26, and media frenzy, and social media conspiracy theories. I think it's time that we looked at some solid scientific data for climate predictions and what that might mean to the British Isles, including the Isle of Man. And if we get through all of that in 25 minutes, you'll be amazed, and it'll be the first time ever for me. So apologies if it goes on just a little bit longer, and apologies to Sarah if you're sat there twiddling your thumbs, waiting for that idiot from the Met Office to stop talking. Okay, let's go for the technology crunch, which is sharing a screen. Okay, guys, my repeat monitor seems to indicate that that might have worked and you've got a shared screen. So that's a great thing, as always, with anything technology-wise. So I would look first at describing to you that the change in global temperatures has already been significant. And as I'm sure most of you are already aware, most of the rise has occurred in the last 20 to 30 years. Various extensive measurements have been taken on the land and on sea, and from many sensors on the geostationary satellites and the polar orbiting satellites that complete the coverage of all the gaps in measurements and data around our planet. Now, this has to be compared to the statistical baselines. Now, typically, for climate change analysis, that means the pre-industrial period of 1850 to 1900. But sometimes a more modern comparison is one of the recent 30-year baselines, such as the one that I will show in a moment. So as I promised at the beginning, we'll go from this big picture, as shown by this EUMETSAT view from the geostationary satellites, to the regional picture, including a little lump of rock in the middle there of the British Isles, and indeed that's a wonderful speck in the Irish Sea that is our home. We'll also have a look at is there a storm coming over the horizon? What's coming next? So let's have a look first at the change in the global surface average temperatures. Here's a global illustration figure from our American friends at NASA. And as you can see, it's based on a baseline of 1951 to 1980. That's one of the popular 30-year baselines. Interestingly enough, most of the rise has occurred, as I've mentioned already, in the last 30 years or so. And it might be interesting to point out that the two peaks that have been measured so far in recent times can be seen there, pretty much equal highest peaks, global average surface temperature records in 2016 and 2020. Now here's a global illustration of the regional differences from 2020 in comparison to the baseline of 1981 to 2010, a more recent baseline. But all the same, the global surface temperature, the mean surface temperature, was 1.2 Celsius warmer than the pre-industrial period in comparison. And in particular, they picked out that the last decade, 2011 to 2020, was the warmest on record when you look at the global temperatures overall. Here's a composite graph from my colleagues and friends at the Met Office in Exeter, and this is consistent to what we have seen already. It has the usual individual data sets that have been collected by various international centres in reference to the pre-industrial period, 1850 to 1900. And in there, it's coming up with the largest rise in temperature has again been measured since approximately the 1990s. So these are individual climate research units, including the one in the UK based at the Hadley Centre, but they're all pretty much in agreement, although they all collected their data sets and analysed them independently. And this is all part of the basis of the data that feeds into the IPCC reports that we hear about, usually just before the conference of parties meetings like COP26. In pretty much the same time period, though, recent decades, the Arctic annual minimum sea ice extent was the second lowest on record, and the trend over the decades can be clearly seen from the data that's been gathered, mainly from satellite coverage, which gives the global overview. And again, it's the Royal Met Society who have brought together their data sets to confirm the global average temperatures are on the rise. At the same time, Northern Hemisphere snow cover is in the decline. And we have also got the prospect there that we have another measure of climate change, namely the rise in global average sea level. And there's also a growing set of data showing the rise of the ocean heat content. It's over a range of depths, as you can see, and as the oceans warm, their volume increases. So we get sea level rise as shown here. And the next slide is the projection of the changes at a regional level across Europe. So that's the rate of rise, and there's the European projection confirming the observed rate of rise. But importantly, if you can see the cursor on my slide, it's showing a rate of rise all around the British Isles between now and the end of this century. And that accounts for all the different climate change scenarios. In other words, all the different emission scenarios that we talk about in climate models. The other big driver, of course, to all these climate changes that are observed and measured and analysed is the so-called greenhouse gases, and the biggest one of those is picked out by this analysis of the Earth's carbon dioxide atmospheric content, gathered from ice cores, for example, from the British Antarctic Survey, to go back that far in time. But as you can see, in 1950, for the first time, we breached the 300 parts per million level of carbon dioxide in the measured atmosphere, and the current level 400 or slightly above 400 parts per million. And look at the rate of rise in the blink of an eyelid. In terms of the age of the planet, this is an extremely rapid rise in carbon dioxide in the atmosphere. It's not the only climate change driver. The other greenhouse gases that are on the rise, besides carbon dioxide, our carbon footprint, are the nitrous oxides and the elephant in the room, that is methane. And of course, I say the elephant in the room, it could be the biggest one in the room because it's potentially a lot more to come released from the ocean seabeds and the frozen tundras as they become thawed out. And we don't know how much methane could be added to the global gas scenario. So that was the big overview. It's time now to move on to this little shiny place in the Irish Sea, and how we've looked at measurements on the Isle of Man. The first and longest record we've got to look at is the record gathered at Douglas, and the Douglas records since 1878 of temperature. So it's a long period record, but all the same, although there's a lot of natural variation, even in the pre-industrial times there on the left-hand side of the graph, and further variation through the last century. This is starting to show a trend in the last portion of the time period over on the right-hand side of the graph, And if you compare that, of course, with the far left, you can clearly see there's approximately a rise from, on average, 8.5 Celsius for the annual mean air temperature at Douglas to something closer to 9.5 Celsius. So over that period, at least a ballpark figure of 1 degree average air temperature rise. We can zoom into a little bit more detail with the data that we've gathered at Ronaldsay Met Office at the airport. And there's what we've been looking at since we've been taking measurements 1947 to the present date. On the top line, you've got the annual mean maximum temperatures, and on the bottom, the blue trace is the mean minimum for the temperatures on an annual basis. And we're looking at the rolling average in the line underneath both of those graph plots. So you can quite clearly see a lot of variation until we get to the 1990s perhaps, and then there's a general rise in the trend line that's in the background. We'll look at how that compares to the average in one of the other graphs I've got, but this is the background average tracking the changes over the decades, the recent decades, maximum and minimum temperatures. If we look at our baselines for the 30-year period, the most current 30-year period is the top line in red, and that's the mean temperature in the period 1991 to 2020, a valid statistical period, that's 30 years. And we'll take it back to the beginning of our period of measurements at the airport. So the other bottom line, the blue line, is the mean temperature in the 45-year period, 1947 to 1991, a longer period, but it's all the period going back to when we started taking measurements. And you can see that annually across all months, we have a rise in the baseline temperature. So the most recent 30 years is consistently warmer than the previous 45 years at Ronaldsay in every part of the year. To bore you a little bit further with statistics, and these graphs are a bit more dramatic. These are a little bit like the hockey stick graphs that are quite famous or infamous from recent analysis of the climate change profile. So the Ronaldsay 15-year running maximum temperature had some minor variation. The scale on this, by the way, if you can't read it, is the bottom of the scale is 12 Celsius and the top of the scale is 13.2. On the left-hand side, we've got 1947 and right up to 2021 on the right. So some variation, small variation in the decades from the 60s to the 90s. And there wasn't much change before that either, by the way. And then you get to the 1990s and we kick off into action year on year on year, decimal decadal increases in our average mean maximum temperature. And then the rate of rise eases off a little bit in the last decade. But overall, we've lifted the mean maximum temperature by the order of 0.8 of a Celsius. More dramatically, the running mean minimum temperature over the same period, between you and me, that's typically the nighttime temperatures, the minimum temperatures, have lifted again more significantly from the 1990s until now, from approximately 6.8 Celsius to near 8 Celsius, a rise of 1.2 degrees over that period of time. And if you think back, that's consistent with the international data sets and graphs that I've already shown you that are observed climate change, temperature rise on the Isle of Man is consistent with the regional and international global figures. Another way of looking at that is a friend called Paul Crane. You may have seen some of his interesting work based on our data sets. He produced the climate stripes graph. I'm not going to repeat those now. Most of you might have seen those climate stripes graphs, which basically look like a rather strange wallpaper, horizontal wallpaper that go from shades of blue up through shades of red at the top end to indicate our changing climate. Less colourful, but the same data is this graph. It's not a graph, it's a tabulation of that base data. And the colours coding on our monthly rise across all the years at Ronaldsway is, if it's coloured red on the right-hand side, that year was half a degree or more above the long-term average. If it's coloured blue, it's half a degree below the long-term average. So in the early decades, there were some rare warm years in the 1960s there, 1959, 1960, some cold years. And then in more recent times, most of the years in the last 20 to 30 years have been average or above average temperatures. And there's only one anomaly. The sharp-eyed amongst you will spot that anomaly there. And that anomaly, surprise, surprise, not, is 2010. You may remember that 2010 across the British Isles started very cold and ended very cold. We had snow and ice brought by a northerly Arctic air mass, and we even had some snow days on the Isle of Man, and the schools had 2 days of extra closure because we even had snow and ice across the Isle of Man. 2010 was also a cooler year because also in 2010, the spring of 2010, we had a volcanic eruption in the Northern Hemisphere, namely that unpronounceable volcano in Iceland. And that volcanic ash in the North Atlantic upper atmosphere would have some effect on the temperature for the 2010. But the main figure there was the cold start and the cold end to 2010 to make that an anomaly in an otherwise a sequence of overall warmer than average years. Also reflected in the minimum temperatures, by the way. So not only were all the days generally warmer, most of the nights were milder throughout the year. Just to emphasise, the most dramatic thing to come out of that at Ronaldsway there is the air frost comparison. And here we're comparing the 45-year period, 1947 to 1991, to the more recent statistical 30 years, 91 to 2020. Quite starkly, in the good old days, we used to get for the Isle of Man, quite a lot of air frosts between the autumn and spring, especially in the winter months there. But in recent decades, we have much less frost observed and measured on the Isle of Man. Another measure of our milder climate generally, including in the winter. So moving swiftly on to the weather impacts. Not all events are related to climate change, but the feeling is from most scientists that we'll see more weather impacts, more extreme, more often. And being a coastal community in the Isle of Man, we might notice that more than others. But in recent times, of course, we've just been reminded that we're in autumn, and we do get belts of heavy rain in the autumn and the winter. Indeed, October has just been the 3rd wettest October on our records, and we end up with scenes like that over the Isle of Man, where you get a lot of standing water, not only on our roads but across our fields. And this is the northern plain of the Isle of Man in the autumn and winter period 2015 to 2016. And the remarkable thing there for me that stands out as a possible example of climate change event on the Isle of Man, in that we ended up having our wettest spell on record for any November to January period since 1947. And there's the league table of the wettest periods in that over the years. And the new one there at 479 millimetres was a big step change up from the other top 5 league table. So it's not unusual to get a step change in records, but it is very unusual to get a massive step change to get a new record breaker. And to me, that was a wake-up call that something more is going on and measurable even on the Isle of Man. And as you can imagine, we set new records for the number of rain days and wet days, a new record of 80 rain days and 66 wet days. A rain day is 0.1 millimetre of rain or more, and a wet day is 1 millimetre or more. Talking of 1 millimetre or more, there we go. Let's look at the statistical analysis of 1 millimetre or more, the wet days, and in recent years, in here, the most obvious standout is a slight but noticeable increase on the number of wet days in October, November and December. And remember that sort of thing, because that's one of the climate change predictors for the British Isles. Not much change elsewhere, but here in the period October to December, an increase in the number of wet days, and the total rainfall during that period also increased to above 100 millimetres on average per month. So the standout ones there are October and November. The other big thing on the Isle of Man we can observe is coastal erosion. It sometimes is more noticeable in some years than others, but it is going on, especially in the northwest of the Isle of Man. The soft sandy cliffs are being eroded by increased rainfall, heavy rainfall events, and undercut by strong to gale force winds and rough seas, cutting in from the side and underneath. And in January and February 2014, the Isle of Man experienced a very rough spell of weather, frequent gales, high tides, heavy rain, and in some parts of the coastline, some fields dropped away by 8 metres. 8 metres of land fell literally onto the beach, washed away into the Irish Sea. How can we look at that? 1954, Glenwillan, people having a nice picnic, a spit of land here, and this property up on the headland. If we jump forward to that infamous spell of coastal erosion in 2014, same place, but it's changed characteristics. That spit of land has been long washed away, even before 2014, and these coastal defences are pretty ineffective. And that property that was up on the headland, it's gone. A lot of the fields and some of the properties dropped into the sea, and there's some more properties not far away from the coastal edge. So it happens on parts of the Isle of Man's coast, and these areas that are at risk have been identified in the JBA report for the Isle of Man government, the National Strategy of Sea Defences, Flooding and Coastal Erosion, and we have found which places have the highest risk from erosion and coastal events and heavy rainfall flooding events. And this is always under review by colleagues in the DOI and DEFA. Climate change, moving on quickly as I exceed my allotted time, is quite simply the British Isles, the Isle of Man. We all have to be prepared to adapt to climate change, and we have to learn to work with climate protections to make plans and understand what's going on. It's important for man, but it's also important for the natural environment to try and cope with the rate of change. These are all the possible, most likely strands in our community you need to know. Just about everybody will be affected one way or the other, and a lot of those apply to the Isle of Man, planners, etc., farmers, infrastructure, yeah, for sure. So it's a circle of response to climate change, which is going to be needed. It's going on, greenhouse gases, that's what's happening in that circle to our planet, and in the outer circle, the impacts and what we've got to try to cover in all these areas, ranging from food security to biodiversity and infrastructure and mitigations. There are predictors that have been done. It's called UKCP 18, Climate Projections 18, and this comes up with the most likely scenarios for a range of emission projections for the climate in our part of the planet. And there's significant changes in that essentially no matter where we are in the British Isles, our summers will tend to become a bit warmer or maybe a lot warmer, and generally we'll suffer some more droughts in the summertime, but also some torrential downpours even in the summertime. The winters will be milder and generally wetter, and all the scenarios under all the emission criteria all come up with a temperature range rise by the end of the century of somewhere between 1.2 and 2 Celsius. If there's high emissions continue, or the highest emission scenario, it could be as bad as a 4-degree rise in temperature across the whole of the British Isles. The UK is coloured in here, not the Irish side, but same, under all scenarios, future UK temperatures will rise somewhere in the mid-range, perhaps between 1.5 Celsius and 4 degrees by the end of the century. What does that mean for the Isle of Man coastal location? Possibly more scenes like this, with high tides driven by more gales. And by how much, you're going to ask? The projections are all parts of the British Isles will experience sea level rise, and indeed the whole planet will have global sea level rise on average. And we should zoom in to the area that's been predicted the most important to us, and that's the figures that came out for Belfast, and a range of projections of rise of up to 52 centimetres by the end of the century. If we have low emissions, if we have higher emissions, it could be as high as 94 centimetres. That's a lot of extra height on the sea level of the Irish Sea. And beyond the end of this century, this plume of scenarios shows that sea level rise will continue for the following few centuries as well. So what can we do? It's all about being aware of the rate of change. All model scenarios give us a warm atmosphere, holding more moisture, active weather fronts, more energy. Weather systems will be more frequent, more often, more extreme. So there's a higher risk of high impact events affecting ourselves. And to us, that means seeing more of that. It might be flooding events on our roads, coastal overtopping and damage to our infrastructure, and summertime heat waves and droughts. All of those are possible under the climate change scenario. And it's the rate of change that we're going to have to get our heads around or slow it down if we could possibly join the international efforts, because otherwise infrastructure, wildlife, ecosystems and diversity are all going to struggle to keep up. The options, like everywhere else in the world, could be for the Isle of Man, let some of it happen, natural changes, albeit they're quicker than what you wanted. Or do you go for hard defences, which can be costly and perhaps time limited? An example here is the flooding in Victoria Road in Castletown in 2014. That won't happen again. Why won't it happen? Because this wall all around Castletown Harbour has been replaced, and that flooded area from 2014 will not happen again because hard defences have been built to protect that part of Castletown, and with a lifespan in excess of 50 years, the cost saved in damage and insurance claims is going to disappear, and the cost of doing those hard defences was way less than the potential costs of the flood damage in Castletown. And similar studies have been done for the other parts of the Isle of Man, notably Laxey and Ramsey, but also for Peel and Douglas. And those things will have to be decided upon over the next 10 to 20 years. The mitigation, of course, besides our local mitigation, the big thing is the Conference of Parties, the COP events that have met up to have treaties, international treaties, taking action on the IPCC reports. Not all countries have agreed to the rule book. There are some big exceptions in the past, including Russia, China, for example, and a rather reluctant and slow India. But everyone's going to have to come to some agreement. And it says next steps, but it's now steps because it's going on now. COP26 has started in Glasgow, and good luck to them that they'll come to some useful ways forward for all of us. And sorry to have exceeded my time, but I promise you that was actually quick for me. And And that's enough from me, and it still leaves some time for Sarah to do her bit next. And I'll be listening to Sarah like everybody else, and I look forward to answering any questions that you've got at the end of the two presentations. So for now, that's enough from me. Thanks for listening.
Right. Thanks, Adrian. I'll just try and see if I can share my screen now. So let's see if it works. I'm assuming everyone can see that.
Thank you.
Yes.
Okay. So thanks, Adrian, for talking about what might happen with the future weather and what's happening at the moment. I'm going to look at how that might impact Manx biodiversity and what nature-based solutions we can look at to mitigate the impact of that climate change, and maybe to even help reduce the emissions from climate change. So before I start, I'd just like to thank the other Manx Wildlife Trust officers for supplying with lots of information about the impact of climate change on Manx species, as well as other experts in the field such as Kate Hawkins, Steve Collin and Ian Scott, particularly for the valuable information on invertebrates. So thank you for that. So what I'm going to be discussing in this webinar is to look at how climate change has already affected biodiversity on the Isle of Man, and what we have lost. And we'll also look at the future impact and what new species we might see as well. So we'll look at nature-based solutions to climate change and the ecological crisis. But it's really important to mention to start with that there is really great uncertainty as to whether it's climate change or other factors which have resulted in the changes of biodiversity that we've seen so far. It is likely that many different factors contribute, including habitat loss and degradation and the use of pesticides. Also important to note is that species vary in their vulnerability to climate change, depending on things such as their diet, their main habitat type, their ecological specialization, and the ability to migrate or be transported. Most of our habitats on the island, such as our heathland and temperate rainforest, and the species within them, tend to be habitats of the northwest Atlantic fringe. And you can see on this map, that kind of habitat is coloured in pink. The Isle of Man is around midpoint in this range, so broadly we should see high resilience to climate change, especially if habitats are kept in good ecological condition and there's good connectivity between habitats. The impact of climate change on biodiversity on the island may also be affected by the fact that we are an island. Some species may not be able to colonise due to their isolation from nearby terrestrial habitats. So this could be a negative factor, leading to an overall loss of biodiversity, but there may also be positive implications, such as reduced colonisation by pests, diseases, and invasive species. Okay, so how has climate change already affected biodiversity on the Isle of Man? Well, if we think about seabirds, they've been significantly affected by climate change. Extreme weather patterns have already affected chick productivity for herring gulls and black-backed gulls, and 8 out of the last 10 years have had low productivity due to prolonged periods of heat or violent storms. And we're in the unfortunate position now that 11 of the 17 breeding species of seabird that we have on the Isle of Man have declining populations. Warmer seas can reduce the availability of food, especially sand eels, resulting in poorer breeding success and lower levels of adult survival for diving birds such as puffins. Sand eels are an incredibly important part of the marine ecosystem and are also eaten by harbour porpoises and larger fish such as mackerel. So the oyster plant is a Schedule 7 protected species, which means it's protected under the Wildlife Act on the Isle of Man. It's a native annual that grows on shingle and less commonly on sandy beaches. And historically, we've had this species in the Ayres and Port Erin Bay and in Castletown Bay. Now, it's a plant that requires very cold winters to germinate the seed. And the last record from the Isle of Man was in 2010. It does have a persistent seed bank, so we may see it again if colder winters return, but the chances of this are decreasing. And the best place to see this now is in the British Isles, is in Shetland. So looking at birds, many species of migrant birds have declined in recent decades. And the calf of Mann records show a significant decrease in many of the summer migrants, such as grasshopper warbler, whinchat, redstart, and pied flycatcher, compared to 64 years ago when the data set started. So these species were all previously considered to be common passage migrants, but are now scarce. And in 2021, there was only one record of each of these 4 species. This may be due to changing weather patterns, such as prolonged drought, but also may be due to declining insect populations and loss of habitat. Many invertebrate species have also experienced a decline. However, there are likely to be many factors contributing to this, including land use change and pesticides. So here, the large yellow underwing moths were very common on the island in the 1980s, with often hundreds or thousands being recorded in one moth trap. But lately, this species is normally in low double-digit or even single-digit figures per trap when in season. So habitat loss caused by climate change is also likely to affect invertebrates and the animals that would depend on them. Increased erosion of soft cliffs on the west coast due to extreme weather events affects a specialised invertebrate habitat, especially where this habitat comes up against improved grassland, inappropriate development, or hard sea defences, and so cannot be renewed. Increased flooding at the Ayers has implications for ground-dwelling invertebrates there. And sea level rise, coastal erosion, and coastal squeeze are amongst the threats to sand dune habitat. Sea level rise is also a threat to salt marsh, which is a threatened habitat here, especially as you know, we've not got very much of it. This has implications for the invertebrates and the fish and birds that feed on them. Increased wildfire due to warm, dry summers may also affect species such as fox and emperor moths, spiders, and ground beetles. Some species depend on upland habitats, which may reduce in extent as a result of climate change. So here we've got the bilberry bumblebee, which depends on good quality heather moorland habitat, which is generally found in upland areas and may be affected by climate change. As well as problems caused by habitat loss and change, there may be an increasing disconnect between insect emergence and flowering food plants. So for successful plant-pollinator interactions, plants need to be in flower at the same time as their pollinators are active. Changes in the length of growing season have resulted in earlier flowering of some plants. And this may have an impact on both animals that depend on specific food plants and an impact on the plants which require specific pollinators. Providing an abundant variety of flowering plants can reduce this problem to some extent by providing nectar and pollen sources for the pollinators throughout the growing season. It's predicted as well that there may be a decline in golden plover as drier summers become more common. So golden plover are one of the species that they breed on peatlands, and their chicks rely on crane flies as their main food source. Drier summers often result in a dramatic decrease in crane flies, as young crane fly larvae are killed when the peat surface dries out. The re-wetting of peatlands is a nature-based solution which can directly impact this species by reducing the chance of peat drying out. So basking sharks, as I'm sure you're aware, were once common in Manx waters. Between 2005 and 2011, an average of 350 basking shark sightings were reported each year, with at least 90 individual sharks identified using fin ID. In the last few years, the number of sightings has declined dramatically, with some years only having a handful of sightings. The status of basking sharks in the North Atlantic has been upgraded on the IUCN Red List from vulnerable to endangered. The cause of this decline is not fully understood, but may be partially due to climate change and the resulting changes in sea temperature variation and distribution of zooplankton. So while the populations of some species have declined or been lost from the Isle of Man, others may increase and new species may arrive. So a warmer climate may mean that new species can colonise further north, but this can only happen if there is suitable habitat for them. Some migrant birds have become increasingly common, such as chifchaff and blackcap. Traditionally, these birds spent their summer in the UK before heading to southern Europe for the winter. But recently, warmer winters have resulted in an increased number spending the winter here instead of migrating south. Some species of wading bird have also expanded their range northwards. Little egret have now colonised the Isle of Man, and there have been recent records of the great white egret. Other species could soon follow if there is suitable wetland habitat for them. For example, Chetty's warbler, which requires suitable wetland habitat. There has been a general northward trend of many invertebrate species. We're now getting multiple new records every year with dragonflies, damselflies, moths and grasshoppers showing rapid and sustained movements northwards. The Devon carpet moth has undergone a rapid range expansion from southwest Britain northwards to reach southern Scotland. Its northern range margin has shifted northwards at 16 kilometres per year, and its abundance has increased greatly, the increase is 526% between 1968 and 2017. So it was first recorded on the island at Manx Wildlife Trust Nature Reserve Erie Staine in 2006, and then again in Laxey in 2008. So other moths which have increased on the island are the footman species of moths, which feed on algae and lichen. Over the past 20 years, the red-necked footman, buff footman, and dingy footman have spread north throughout Britain and have all now arrived on our shores. It is believed that reduced air pollution and climate change are involved in the spread of the footman moth. 2020 saw the first records on the island of the crimson speckled moth, which is normally a resident of North Africa and the southern Mediterranean. Whilst the 2020 records coincided with a large influx of migrant species from the continent across Britain, it is likely that climate warming will enable more such species to arrive, survive, and potentially become resident if our winters are not too harsh and suitable food plants can be found. So, what are Manx Wildlife Trust doing? Well, Manx Wildlife Trust are trying to minimise the impact of climate change on biodiversity on the island by creating more places for wildlife. Species in good condition habitats are more resilient to climate change. If these habitats are connected, it allows easier movement of species in response to climate change, for example, upslope. Manx Wildlife Trust are also aiming to enable nature to improve our environment and help us to achieve net zero emissions. Nature-based solutions can improve water quality, reduce the risk of flooding and wildfires, reduce carbon emissions, and increase carbon sequestration. Nature-based solutions should not focus solely on carbon sequestration. They need to consider the ecological crisis we are in as well. For example, planting native woodlands has more benefits than planting conifer plantations. Wildlife trusts across the UK are pursuing nature-based solutions to climate change and the biodiversity crisis. In our marine environment, this involves the protection and restoration of blue carbon, including seagrass and salt marsh. On land, we're looking at the restoration of peatland, woodland, grassland, and wetland habitats. So over the last few years, I've been working on upland peatland on the island. So this picture here shows an example of a peat hag, and you can see the exposed dark peat there, which dries out and erodes away, releasing carbon dioxide. The Manx Wildlife Trust are working with DEFRA to restore the damaged peatland. So far, we've worked together to undertake a pilot restoration project at the old Turbury site on Benny Pot. There are plans to restore 1,000 acres of upland peat in the first of a series of restoration projects. The peatland restoration can reduce flood risk, improve water quality, and reduce carbon emissions. It can also increase carbon sequestration and improve peatland habitats. So initially, a large-scale survey of the extent and depth of the upland peat has enabled us to highlight key areas where restoration is needed. This survey has been helped by volunteers, some of whom are continuing to collect data. We've also had help from upland farmers, and this slide here shows Anna and Ferric helping to measure the peat depth on the land that they farm. So this picture of Derby Mountain Nature Reserve is an example of how a peatland in good condition might look. It supports a diverse range of plant and invertebrate species, which in turn support birds such as curlew. A bog in good condition is more resilient to wildfire and other effects of climate change and provides a good habitat for invertebrates and wetland birds. So Manx Wildlife Trust are also involved in tree planting to create habitats and sequester carbon. And this is our intern Hannah planting trees in Glen Alden. Manx Wildlife Trust is working with corporate groups to plant microforests. These are small woodlands which will sequester carbon, provide new habitats, and increase the accessibility of woodland for people to enjoy. Ramsey Forest Project is a partnership between Manx Wildlife Trust, Rotary, Isle of Man Government, and the Ramsey community. It is working to create the island's first forest by expanding and linking the glens, plantations, and woodlands between Ramsey and Sulby. It was launched in 2014, and the aim was to increase the woodland cover from 20% to 30% over the next 30 years. Funding is in place, and the project is set to develop greatly in 2022. Connected and protected landscapes such as this help to mitigate the impacts of climate change on biodiversity, and they also help to connect people with nature-based solutions. And that picture here shows us working with corporate groups and volunteers to plant trees as part of the Ramsey Forest Project. The Manx Wildlife Trust have created and manage nature reserves, which are great for biodiversity and improve resilience to climate change. Meadows such as this one at Goshen are also good at sequestering and storing carbon. Seagrass restoration is an example of blue carbon as a nature-based solution. Seagrass beds are valuable marine habitats, providing a nursery habitat for a range of small fish. And they are also important carbon sinks, storing carbon in the plant above and below the sediment. Seagrass beds have declined. Oh, sorry, go back a minute. Seagrass beds have declined by 90% in the North Atlantic since the 1930s due to a range of factors, including pollution and other human activities. And this slide here shows our marine officer, Lara, surveying seagrass beds. The Manx Wildlife Trust is working with partners to survey these seagrass beds, which can then be protected by law. Since the designation of marine nature reserves on the island, seagrass in protected areas has expanded significantly. Seagrass restoration has been identified as an important way of sequestering and storing carbon, and thereby helping with the global goal of net zero emissions. And Wild the Carbon is a Wildlife Trust offsetting scheme, focusing on large-scale restoration of native UK habitats to create wildlife-rich, climate-resilient landscapes that lock up carbon. So whilst carbon offsetting is not the solution to climate change, it can help with the restoration of habitats, which can help improve our resilience to climate change. This slide shows our conservation officer, Andre, working with Simon. Simon worked with Manx Wildlife Trust as an intern, focusing on creating a carbon offsetting standard for the Isle of Man. And we're now working with KPMG and the Isle of Man government to develop this carbon offsetting scheme. So the restoration and creation of habitats as part of nature-based solutions to climate change can also create a nature recovery network. This is a joined-up system of places important for wild plants and animals on land and at sea. Protected habitats allow species to persist longer at the edge of their range. Connected habitats allow easier movement of plants, animals, seeds, and nutrients and water from place to place, allowing them to adapt to change. Manx Wildlife Trust are helping create a nature recovery network by working with partners to improve the quality and connectivity of terrestrial and marine habitats across the island. We are now the delivery partner for the Agri Environment Scheme. The scheme provides support for initiatives that create habitats, enhance biodiversity, sequester carbon, improve water quality, reduce flooding, and reduce carbon emissions. 88% of the Isle of Man is under agriculture, compared to just 0.2%, which is a Manx Wildlife Trust nature reserve. So by working with farmers, we aim to have a much greater impact across the island for nature. So the protection of marine habitats is very important in order to mitigate the effects of climate change. By improving habitat condition, we can increase the resilience of species to the effects of climate change and also protect the carbon stored in the marine environment. Since 2018, 10 marine nature reserves, hang on a minute. So since 2018, 10 marine nature reserves have been created, and habitats within these reserves are protected from damaging activities. Wildlife trusts in all 6 nations are now collaborating to drive more holistic approaches to nature-based solutions and create an Irish Sea nature recovery network. In 2015, the UN outlined 17 Sustainable Development Goals. Nature-based solutions tie into many of these goals. For example, into number 6, protect and restore water-related ecosystems, including mountains, forests, wetlands, rivers, aquifers, and lakes. Number 13, strengthen resilience and adaptive capacity to climate-related hazards. Number 14, sustainably manage and protect marine and coastal ecosystems to avoid significant adverse impacts. And number 15, ensure the conservation, restoration, and sustainable use of terrestrial and inland freshwater ecosystems and their services. So, to summarise, the implications of climate change on the biodiversity of the Isle of Man are not yet fully understood. There has already been a loss or decline of some species, and climate change is likely to be one of the factors causing this. Other factors, such as habitat loss and degradation, are likely to have had a bigger impact on biodiversity up to now. However, we are likely to see an increase in climate change affecting biodiversity in the next few decades. This may include further declines in some species and the reduction of some habitats. We have also seen the arrival of new species, especially those which can fly. The fact that we are an island may have some positive and some negative implications. We need more protected habitats for wildlife with better connection between them. Nature-based solutions to climate change should also improve habitats for wildlife and create a nature recovery network. Our work on nature-based solutions aligns with global sustainability goals, and we have been involved in Isle of Man projects to discuss the role of biodiversity and nature-based solutions in tackling the climate crisis. And this slide shows a recent event based around the Isle of Man documentary Time Enough, which focuses on climate change on the Isle of Man. And I was part of a panel discussing climate change in a Manx context. So as an island, we must do our bit, and our biosphere could become a leading example of how a small island can use nature-based solutions to mitigate climate change and enhance our wider environment. And this will be for the benefit of biodiversity and the health and well-being of the people who live here. Okay, and try and bring the screen up now and stop sharing. Okay.
Thank you, Sarah. Thank you, Adrian. Wow, I feel like I've learned so much in the last 60 minutes. Were both really, really great presentations. Thank you very much. And now I guess we can open to questions. So if anyone has any questions, I guess the best way forward is to type your questions via the chat function. I've got a first question here, so I'll just crack on. The first question is for Adrian. As you stated, an ever-warming atmosphere means increased capability for more moisture in the atmosphere and subsequently increased flood magnitude and frequency. What do you think are the best and most practical river and coastal flood defences for the Isle of Man, given that we have to plan for more extreme weather events which were previously considered once in a lifetime?
Okay, very good question. I think it's no simple answer for the overall range of flood risk areas on the Isle of Man, whether it's the rivers or the coastal defences. I think it's a watching brief, and currently a multi-agency government committee meet and review that JBA National Flood Strategy document and risk areas every 5 years. And that's based on the latest data and modelling. And it also, at the same time, will look at a cost-benefit analysis. So when you can identify those places that have got the highest risk and yet a mitigation protection by strengthening, I suppose, the infrastructure of walls or lifting the height of walls, for instance, if that cost-benefit analysis shows it's worth spending X amount of pounds to save Y amount of damage. But that's a changing landscape, how you do that, and we'll have to rely heavily upon technical experts, civil engineers, and I suppose always keep an eye on also including our natural environment colleagues who may be able to suggest ways of, like Sarah mentioned, using natural mitigation techniques in a combination with man-made techniques. And that is one project that's underway on the Manx uplands at the moment for flood risk mitigation. And I think that's going to be very successful, for instance.
That's great. Thank you. We've got a couple more questions. Shall I read the next one? The next one is for Sarah from Robert Mercer. How much of a problem does agricultural groundwater runoff and pollution from untreated sewage pose for our marine reserves?
Yeah, okay, thanks for the question. I'm actually going to see if I can hand it over to Lee Morris, who is one of our marine experts. I don't know if Lee, you're able to answer that one.
Hi, Sarah. I will try. I probably need Dr. Lara with us, but undoubtedly agricultural runoffs globally impact. You know, nitrates going into the ocean make a difference. I think, for me, I think it comes back to the Irish Sea in the context of how does the Isle of Man fit into this, and I think what we do in our agriculture matters. And ironically, if we can help and work with farmers to reduce, you know, the inputs into the soil, then that may have multiple benefits, including for the farmers' pockets in terms of money that they've got left. So I think our ambition through the Agri-Environment Scheme and the delivery of it is in many ways is to reduce the negative impact of what agriculture has in terms of runoffs into the ocean, and at the same time help the farmers be sustainable in what they're doing. So that would be the overall. But does it have an impact? Yes. Does it impact on things such as seagrass? Yes. Could we do it better? Yes. And I think we can make our island a really, really great example, as Sarah says.
Thank you, Lee. Oh yes, I forgot to mention that Sarah is supported with the rest of the team of the Manx Wildlife Trust to help all the Q&A at the moment. So the next question for Adrian. Adrian, have you looked at any wind climatologies? I mean, statistics on how wind speed and directions have changes between the long and shorter climate periods you presented?
Hi, good question. We do look at wind climatology, and it's one of those areas where there's no clear trend either way in changes in the frequency of wind directions or speeds yet. I fancy that in the next 50 to 70 years, we'll start to see something of a trend arising as weather patterns in the North Atlantic start to be modified by climate change, and the more active, energetic atmosphere produces more storminess. I would expect to see an increase in frequency of strong winds or gales or storms. But the data gathered at Ronaldsway since 1947 for wind climatology has not yet identified a trend in that respect. And it's even early days for the rainfall trend, as I indicated. There's just small signs of a start of change on the climatology of rainfall. But so far, no change on the wind roses, the wind climatologies that we gather.
Great, thank you, Adrian. I think the next question is again for you. How long, and this is from Sarah, how long is the time lag between cause and effect in terms of temperature changes? I appreciate that this is a very vague topic, but I wondered what caused the spikes in some of Adrian's temperature graphs, i.e. was this something that happened in the same year, the previous year, or well before then? And also how quickly our efforts to tackle climate change will start to bear fruit. And she says, I appreciate that this depends hugely on what we do and how we do quickly.
There's a lot of questions in there, isn't there?
Yes, yeah.
But yeah. Generally speaking, short-term changes, as represented in those temperature graphs, are not necessarily all climate-driven. In fact, they're almost certainly mostly weather pattern-driven. So, for instance, that year in 2010, where there was a dip in the average temperatures, that was driven by the fact that the two seasons, the beginning and the end of the year, had weather features that introduced northerly winds over the British Isles in both December and January in that year. I think really that the thermal lag between oceans and the atmosphere and climate change would really have to be measured in periods of at least 5-year blocks, but preferably the decadal or the 10-year blocks would be a more clear indicator. And the changes in the oceans are even longer period than that. Hence, one of the statistical periods that's considered appropriate for measuring change purely driven by climate change is those 30-year baselines. All the variations and spikes and dips in the meanwhile are usually mostly driven by weather patterns, either on a seasonal basis or an annual basis. I don't know if that covers all that question or not.
I think so. And how quickly efforts to tackle climate change will bear fruit. And I guess it depends on what we do and how we do it.
I totally agree with that. And no matter what those efforts are, stabilising or plateauing, flatlining the rate of rise is probably achievable in the period of a few decades. But reversing, if it's at all possible, the reversing will take more than that. I would say, if you're lucky, 1 or 2 centuries to start to reverse. So I would like to hang around to see all those things happen, but that's not going to happen, is it? But we have to think about children and grandchildren and beyond is the key message there.
Thank you, Adrian. The next question is for Sarah from Philippa. Sarah, you talked about upland heathland restoration, but what about all the lowland wetlands from wet grassland to bog that we have? Many have been drained and are drying out. What's being done to protect the carbon in this wetland?
Absolutely. The lowland peat and the lowland wetlands are just as important as the uplands, if not more. A lot of our carbon that is released is from lowland peatlands that have been drained or currently under agriculture. So you're right, it's absolutely crucial that we try to do something to restore these. It's possible that it's something that the Agri Environment Scheme can help to deal with, because, like I say, a lot of the lowland peat that is drained is under agriculture. We have challenges though, because it's under multiple land ownership. So there are lots of challenges, but I think it is a really important area to look at. Yeah, I don't know if that's answered your question.
I think it did. Thank you, Sarah. Another question for Sarah. Did you touch on seagrass? I think you did. Is it true that it absorbs 10 times the carbon of the average tree? What potential does the Isle of Man have for planting seagrass on the near shore?
Okay, so yes, I believe, like I say, I'm not a marine expert. However, I do believe that seagrass absorbs a comparable and stores a comparable amount to a rainforest, so a good seagrass bed, which seems unlikely, but apparently it is the case. We do have some seagrass areas on the island that historic areas that have declined due to pollution and disease, and some of these have started to return since we've had marine nature reserves protecting from damaging activities. It does require quite specific conditions, though. It requires shallow water. So I think sort of an average depth of sort of 2 to 3 meters at low tide would be about enough. Any more than that and it won't get enough sunlight. And it also requires a lot of shelter from stormy weather. So the seagrass you find currently are in areas that are generally fairly sheltered. So I think we have got scope to expand it. Don't know if you would like to add any more, Lee?
I've been having lots of conversations about this recently. I'll keep this short. So I think it's a really potentially important topic. I know there was a workshop last week that Dr. Lara joined, run by the government, by our government, which I think I'm told was really successful, and I've seen the paper. So there are areas around the island with seagrass. I've dived quite a few of them now. Some of them are quite sparse. They could be restored. There were certainly areas that used to exist in the past of seagrass. There's 2 particular areas in Port Erin Bay. Now there is some debate as to whether that seagrass isn't there now and it wouldn't be appropriate to put it back. I think there's some good questions, but certainly the opportunity to look at that and maybe enhance what's around the island, maybe restore some seagrass to places where they used to be is important. The one other thing I would say very quickly is that I think in terms of blue carbon, Sarah's mentioned seagrass and she's mentioned and we've talked about the salt marshes. One of probably the most important areas for blue carbon is the blue carbon that's locked up in the seabed, and about keeping the blue carbon that's in the seabed. And I think that could be a more and more important topic as we start to put a value on the actual seabed that's around the island, because there's a huge amount of the Isle of Man territory is underwater.
Great, thank you. That's a very comprehensive answer, I think. This is a question for Adrian next. I'm not sure if it's something. Well, question for Adrian. In your opinion, where's the best place for wind turbines?
Yes.
Or offshore?
Well, yes. Opinions will have to be my own rather than having my Isle of Man government hat on as a civil servant. But actually, as a weatherman, the most sustained winds and reliable winds are to be had offshore. That's because on land, although you think it's always windy on our hills, it's not always windy on our hills. You can get what are called atmospheric inversions, which cut off the wind on some occasions over the land, especially at night. So if you're wanting to consistently generate usable power from wind turbines, you go to where the wind is the most consistent, with little change between day and night, because there's less friction over the sea than over the land. You also generally will have higher average wind speeds, as well as more breeze day and night over the sea than the land. So the best places, from a weatherman's point of view, to place wind turbines is offshore. That might not suit some communities or politicians, or it may also not suit some civil engineers, because the civil engineering challenges of building offshore, I'm sure, are much greater and more expensive than building on the land. But there you go. There's my sort of answer, personal opinion.
Thank you, Adrian. I think the next question is for you again. Is there a danger that building hard coastal and river defences to protect people and property will give us a false sense of security and divert attention and resources from measures to reduce carbon emissions to measures for mitigating the impacts? It seems that the natural solutions discussed are relatively cost effective. That's an interesting question.
It is indeed, yes. I think every project and scheme always has to be considered individually with the best data at the time. As I say, I think there's a lot to be said for a review every 5 years of the cost-benefit analysis. Also, every 5 years, the technology and methods and techniques for providing mitigations will probably change as more research is done. So what might be appropriate for 2021 may not be the same approach you would take to mitigate flooding on the coast or in the rivers 10 years later with more knowledge and data. I think the mix and match approach that's appealing to me in terms of flood resilience is work with nature and limit the extent of man-made structures. And by doing that, you're not producing such a carbon footprint when you're producing those man-made structures, whether they're made of steel reinforced concrete or whatever. Very delicate balance, and I think that's why we'll need more technical people, scientific people and engineers to figure these things out and make the recommendations to politicians who will then make the decisions.
Great, thank you, Adrian. The next question is for Sarah. Sarah from Kate, I'm interested in your mention of the Nature Recovery Network. Is there any effort underway to link gardens, park, urban verges, etc. with the countryside to enhance habitat connectivity?
Ooh, interesting question. I'm not aware of anything that's currently linking sort of gardens and sort of in the urban environment, but I'm trying to think now. We have with the Agri environment scheme and the wilder communities projects that we're doing, we're hoping to link large scale landscape, so create large scale landscape networks. So that could include sort of tree planting that connects different areas sort of farmland, but maybe separate farms, but with sort of some connectivity between them. Like I say, Andre's working on Microforest. So I don't know if Andre is on the conversation, whether he'd have more to say about that. Maybe he's not. But yeah, we're trying to work on projects that do kind of link in sort of habitats on a landscape scale. But I do think it'll be an interesting one to try and link urban environments and hedgerows. We're looking at a scheme of what's known as green lace, which is kind of looking at all the hedgerows across the island, of which we've got numerous hedgerows, and how to improve them for biodiversity. So it kind of looks like a green network of sort of small wild places across the island. So hopefully that will increase sort of a nature recovery network. I was hoping Andrew would be in the conversation as he's our expert on this, but he doesn't appear to be at the moment. I don't know if Lee, you have any extra knowledge on what he's planning?
I'll be very quick. The one thing I'd add, well done, Sarah. The only thing I'd add that you haven't said is around wildlife gardening. So the wildlife, what people can do in their own little space of the Isle of Man is really important to us. And we're having some really good discussions with the Isle of Man government again around DEFRA and around how we can get an accumulator so that people in the island can really feel that they're doing their bit and adding their little bit of the island to our nature recovery network accumulator. So things are in traction for that. But as Sarah said, agriculture, nature reserves, areas of interest, all those things can add together. But wildlife gardening. So that's our hope.
Brilliant, thank you. I think we've kind of answered all the questions. Any more questions for Sarah or Adrian? No. Let me see. It's 8:21, so we've come very close to the end of this presentation. If there's no more questions, I think we can call it a night. So before we finish, I just wanted to say thank you to Sarah and Adrian for the really insightful presentation. I learned lots tonight, and I hope everyone else too. And to everyone else, we'll be recording. Well, it is being recorded, and we'll share this on our YouTube and on our website. And just to let you know, as I mentioned earlier on, we've got a program of events. So tomorrow we have, very lucky to have Nicole Stott, who is a NASA astronaut, on our webinar, and she will share with us her own personal experience of being in space and looking back to Earth and thinking about, wow, how we need to work together to save our planet. And I, for one, am very excited about that presentation, and I hope you are too. So you can still register for this event. Visit our website for more details. And next week we have Professor James Curran, who'll talk about the link between biodiversity crisis, and Rebecca Nestor, who will talk about talking climate change. And if anyone's interested in tree planting, on Sunday there is a tree planting activity run by the Woodlands Trust in Foxdale, and information is on our social media and on Facebook. With that, thank you everyone for joining us today. Thank you, Adrian. Thank you, Sarah. Good night.